Good morning, guys. I hope you're doing well. So this is our first e-learning day. So I will put the lesson online so you guys can watch it. And then the homework will be dealt to math, and it won't be due until tomorrow, just like normal. So if you have any questions, please let me know. Feel free to come during office hours or send me Schoology messages if you guys need anything throughout the day. So today we are graphing inequalities. Yesterday we graphed systems of equations. And today we're going to do inequalities. So just a reminder, inequalities, instead of an equal sign, we have our greater than. We have our less than sign. We have our greater than or equal to sign. And we have our less than or equal to sign. And just a reminder, these ones were open circles, and these ones were closed circles. We'll talk about that here in a little bit. So the first section of today's notes, tell whether the ordered pair is a solution to the inequality. So we did this yesterday. The 2, -2 is my x. The -3 is my y. I'm going to plug in -2 for my x. I'm going to plug in -3 for my y. And I'm going to say, hey, is this a true statement or not? So -2 would be +2. -2 times -3 is greater than or equal to 5. So order of operations, I have 2 minus 2 times -3. So I'm going to do this multiplication first. -2 times -3 gives me +6. So when I do this, I end up with 8 is greater than or equal to 5. So I have to decide, is this true? Yeah, 8 is greater than or equal to 5. So then, yes, that ordered pair is a solution. Go ahead and try the next one. And you can pause the video. The next one, I'm going to plug in -1 for x, and I'm going to plug in -1 for y. So I should end up with 3 times -1 is -3. Then I have -4 times -1. -4 times -1 gives me +4 is greater than 6. -3 plus 4 is 1. Is 1 greater than or equal to 6? No, that's a false statement. So no, this is not a solution. Then we've got some word problems, some things to note about the word problem. I'm not even going to read it yet, but they go ahead and give me my inequalities, which is nice. So we don't have to write those just yet. We'll do that in the next section. So here it says I have $150 to spend on video games. Now, if they didn't give me these, just a reminder, I could do my more, less, equal. If I have $150 to spend, can I spend more than that? No. Can I spend less than that? Yes. Can I spend equal to that? Less than or equal to, which is the sign they gave me. Okay, so just giving you the reminder of how to write them. X is our number of used video games. Y is our number of new video games. So X, they tell me, is my used video games. And Y is my number of new video games that I can purchase. Now, they didn't give me the information in the word problem, but they gave me the problem. So from here, I could tell, hey, $150 to spend. X is used video games. Those are $7. and my new video games are $32. So even though they didn't say it, I know that because they gave me the inequality. But here it says, can I purchase 10 used video games and 3 new video games? So I have the point 10. And again, X is used video games, 3 new video games. They want to see if this makes a true statement. So 7 times 10 plus 32 times 3, is that less than or equal to 150? So 70 plus 96 is less than or equal to 150, which gives me 166 is less than or equal to 150. Is that a true statement? No. So could we buy that? No. It costs $16 more than what we have. Because the problem also said, explain. Go ahead and pause the video and you try number 3. So here we have the inequality 9x plus 5y is greater than or equal to 60. This represents the number of X newspapers and the number of Y magazines we must sell to earn enough points to earn a special school lunch. You sell 4 newspapers and 6 magazines. Do you receive a school lunch, special school lunch? Explain. So 9x plus 5y is greater than or equal to 60. They told me I sell 4 newspapers, which is X, and 6 magazines. So 9 times 4 plus 5 times 6 is greater than or equal to 60. So 36 plus 30 is greater than or equal to 60. Is 66 greater than or equal to 60? Yes. So yes. Explain. I have enough points. Next problem says, Eli and his children went to a movie theater and will buy bags of popcorn and pretzels. Each bag of popcorn costs $5 and each pretzel costs $4. Eli has a total of $30 to spend on popcorn and pretzels. Write an inequality that would represent the possible values for the number of bags of popcorn purchased, B, and the number of pretzels purchased, P. So in this case, we're not solving anything. We're not seeing if it's a solution, but we need to write our inequality. So we have $30 to spend. If I have $30 to spend, can I spend more than that? Can I spend less than that? Can I spend equal to that? Well, if I have $30, I can't spend any more than that. I can spend less than that, and I can spend equal to that, so less than or equal to. Number of bags of popcorn purchased, B. So popcorn is $5. That's going to be 5B. And pretzels cost $4, 4P. The only thing I need to think about is what operation. If I buy 1 bag of popcorn and 1 pretzel, $5 and $4, I spend a total of $9. I need to add those together. Next it says Jace has nickels and dimes. He has at most 20 coins altogether. Write a situation as the inequalities. So nickels and dimes. And this was like a lot of the word problems you guys had yesterday that I wanted you to try. So he had at most 20 coins, so 20. At most. If I say you can have at most 1 cookie, can you have more than that? No. Can you have less than that? Yes, and we can have equal to that. Does this problem talk about money at all besides nickel and dimes, like how much they're worth or that he has $1.50 or anything like that? No. So they're just saying between nickels and dimes he has 20. So this would be n plus d is less than or equal to 20. Next it says the inequality is graphed without shading. Find the problem by shading the correct solutions. So first thing I want you to notice, some of these lines are dashed. And one is solid. Look at the inequality signs that match it. On the page before, we said normally our greater than or less than had open circles when we were graphing them on our number line, right? And then we could shade. When we're talking about inequalities, because we have an x and y axis, now we are going to have dashed lines for greater than or less than. If we have greater than or equal to or less than or equal to, it's going to be a solid line. And that's because the solid line includes those values because they can be equal to them. The dashed lines, it doesn't include. Okay, and we'll talk about that again as we move forward. So one way we can do this is y is greater than or equal to 6x plus 1. If we want to check if it's a solution or not, I'm going to pick the easiest point I have, which is the point 0, 0. And I'm going to plug it in, which gives me 0 is greater than 0 plus 1, which is 1. Is this a true statement? Is 0 greater than 1? No. So that means where this point line is not my shaded region, it's not my solution. So since it's not below where 0, 0 is, it has to be above. So here my solution region is above the line. Here, if I test out my point 0, 0, and this is just easiest to plug in because it makes everything cancel out. So it would make this negative 2x cancel out. Is 0 greater than negative 3? Yes, that is a true statement. So here is my solution region. Again, it's super fast. 0, 0. If I plug in 0, my x would cancel out. Is 0 less than or equal to 3? Yes. So that means this area is my solution region. Now, if you're like me, you don't want to have to plug in points every time. So I'm going to show you another thing that I do. So if you're like, hey, Mrs. Hoppy, I don't want to do that extra math. Here I have y is greater than 6x plus 1. I'm going to highlight my line. Greater than means it goes above. Above, above. So this is the region that should be shaded. Here, this is x is greater than, or sorry, y is greater than 2x minus 3. I'm going to highlight my line. It's greater than, so everything above this line should be shaded. This is y is less than or equal to. I'm going to highlight my line. Below it, so this region should be shaded. Next, it says write the inequality that's graphed. So we're going to start with that. So here, my y-intercept is 2. I have y. My shading is below the line, and it's a solid line, so less than or equal to. My slope, I'm just going to double check. Down 1, right 1, down 1, right 1, down 1, right 1. So it should be a negative 1. So here's my inequality. For my point to be a solution, it should be in the shaded region. So here I have the point 0, 2, and I have the point 2, 2. 2, 2, I can totally tell is not in my shaded region. It is not a solution. But 0, 2, I'm going to check out, and I'm going to put in my xy points just to show you. So I have 2 is less than or equal to negative 0 plus 2, which is just 2 is less than or equal to 2. Is this a true statement? Yes, because it's equal to it. So I'm going to put a little note here. If point is on a solid line, it is a solution, because it can be equal to it. For number 10, I'm going to go ahead and start writing my inequality. So here my y-intercept is negative 1. My shading is above the line and it's dashed. And here I go up 1, over 1, 2, 3. Down 1, over 3. Yep, that looks good. So 1/3 x. Now I'm going to test out these points. 3, 0. And negative 1, negative 1. That one I can see, yes, as a solution. This first point lies on a dashed line. So again, I'm going to plug this in. So I end up with 0 is greater than 1/3 times 3 minus 1, which is 0 is greater than 1 minus 1, so 0 is greater than 0. Is this a true statement? No. Because it's not equal to, it is equal to it, but it's not greater than it. So if point lies on a dashed line, it is not a solution. Okay, go ahead and pause the video and you try the next two. Okay, hopefully you paused it. So here I can see my y-intercept is negative 2. I go up 1 over 2. It's a dashed line and my shading's above. So I should have y is greater than 1/2 x minus 2. My first point is 2, negative 1. So 2, negative 1. It's on the dashed line. No, it is not a solution. I don't need to check and do it mathematically anymore. I wanted to make sure that you guys understood those points. So if it's on a solid line, it is a solution. If it's on a dashed line, it is not. 0, 0 is in the shaded region. We're good. Next, I have the point 3, 3. It's on a solid line. Yes, it is a solution. Negative 3, negative 1. Double check my points. Yes, it is on there. My inequality I have not written. My y-intercept is positive 1. My shading is below and it's a solid line. And here my slope is up 2 over 3. So hopefully we feel confident that 1, we can write an inequality, but 2, we know if a point is a solution or not given a graph. And then here we're only going to do just a few problems. We're going to do 13, 14, 15, and 17. If you want to do the rest of them, you're more than welcome to. So graph the inequality on the coordinate plane. So why we're doing 13? It's only one variable. So this reads y is less than 4. This means it's going to cross my y-axis because it's only one variable. It's going to cross my y-axis at 4. The less than or equal to tells me that it's a dashed line and I'm going to shade below. So here is my dashed line. I'm going to highlight my line, and I'm going to shade below, so it should be less than. So this is everything below that line. Again, this is one of my special lines, and that's okay. For number 14, I have x is greater than 3. So this I know is dashed, and technically I'm shading above. Now x is greater than 3 is one variable again, so 3. This is my horizontal line. So again, I'm going to shade, and I'm going to color my line. Now, it should be above this line, which really just means all my values should be greater than it. Which direction are my x values greater than 3? Well, here I can see this is 2. Is 2 greater than 3? No. So here, 4, 5, 6, 7, 8, and when it goes on forever, are x values that are greater than 3. So that's your tricky one. But again, just think about it and say, hey, where are my x values greater than 3? Number 15, I have y is less than 3x plus 1. So here, I know this is going to be a dashed line, and I'm going to shade below. So I'm going to start graphing. My slope is 3. My y-intercept is 1, or 3 over 1. So I'm going to go to 1, and I'm going to go up 1, 2, 3 over 1, 1, 2, 3 over 1. And I'm just going to do it for my whole graph. And this should be a dashed line. In Delta Math, you'll be able to click the line and it'll change from dash to solid. And then we said below, so I'm going to highlight the line. Below the line is this way. So that is going to be my shaded region, my solution area. They also call it your feasible region. And then my last one is not in slope-intercept form, so I wanted to do this one in particular. I'm going to subtract x from both sides. So I have negative y is less than negative x plus 2. Hopefully you're still watching the video at this point, because this is the number one thing kids miss on assignments or assessments. To get y by itself, I have to divide by a negative 1. When we divide inequalities by a negative, remember we have to flip our inequality sign. So I end up with y is greater than x minus 2. So here should be a dashed line, and I should shade above. And from here I can graph my y-intercept is negative 2, my slope is 1, dashed line. They're so close I don't even really need to put dashes. Highlight my line. My shading should be above. So above is this direction. And I'm done. So again, if you guys have any questions, feel free to hop on during office hours. But please, please, please ask questions, and we will see you tomorrow. Stay safe in the snow.